I would like to thank Shri Rajiv Sharma, Mr. Bhaskaran, and other senior dignitaries besides police officers. As you are aware, this project was started by Harsimran and my senior DST coordination. Experience in client server rights. We had developed the application for rights, which is still running with rights. We are building an inspection application. Presentation. This is about the roadmap. It has come up with an idea. Roadmap and how do we collaborate? What are we expecting so that we can end up with a predictive maintenance tool? So this is the purpose of this presentation. I'd like to be as brief as possible so and I can let you understand the issues that are concerning us. As explained, IT administrators and system operation managers generally collect and aggregate logs in a central location. These logs can be used to perform root cause analysis and remediation. In cases, the analysis takes place after the incident has happened, which leads to significant downtime and disruption. But by bringing machine learning to log analysis, the system becomes smart and can detect anomalies and unusual patterns for the end user experiences and results in the system. Next slide, Harsimran. So this is what Harsimran has done in a small glimpse. One problem with the power cables account for about 6.6% of all the 9% of the late rain moments. Restore is about 2 hours, 120 minutes. He has analyzed data for about 38 cases of analyzed 5 lakh samples in a 2 months. He has created it in MATLAB software. It is a Reddit, not industry standard. And he has created a classifier predicting an accuracy with the results he has achieved 86 failure with his classifier 26 days before. Go forward, we have approached IIT Madras. And IIT Madras has come forward critical professors, specialization in instrumentation, and there are other in mathematical modeling. We plan to go forward. Next slide, Harsimran. So as Indian Railways, we have always been doing corrective and preventive maintenance. So this attempt is to have a paradigm shift forward into predictive and prescriptive maintenance. Artificial intelligence takes over and human interference is minimum. As you can see in the slide, data, and then we used to have descriptive accounting of the data, diagnostics, then we did predictive, but in all these cases, the light green portion shows that the human element is still there, but when you go to the current method of supports decision, the content of human element is totally disappearing. In a decision automation, the machine takes over. The decision is also taken the data directly into action. So thus we eliminate the human element actually taken by the machine. Taking the same definitions of artificial intelligence, it is that part of the computer science that emphasizes the machine will take over the activities of the humans. So in that area, Indian Railways is not into that realm of work. It's us to a near because he has an algorithm that thinks. It's a method of data analysis basically. It is a part of artificial intelligence. Being that data, if you keep on refining data and giving it patterns and make decisions, thereby either reducing human intervention or altogether removing human intervention so that the machines can take the decisions and take remedial action. So these are some of the concepts that Harsimran has already. He has done in Chennai edition with the senior DST Mr. Babu is, first they analyzed the failures of signaling power cables. After analyzing, they realized that an algorithm that is a mathematical model to predict the failures. And once classifier and predicted that future failures almost with an accuracy of 26 days in advance of an event that is occurring, the system has taken over a part of the work, a stage to which we wish to go. This in Chennai division for one one field of their activity, that is power cables. Next. The future program that Harsimran, Senior DST, and we have, the model 1 is totally with data. It's a data aggregator. It has from the front-end processors, data to the front-end processors. From these front-end processors, the server collects the data. But of course, presently, all this data is proprietary technology of the person who maintains the data loggers and the data that is, and he has given us certain applications to work, but we do not have our own applications. So this application is a development outside his peer, his proprietary. This is a development by our officers from the data loggers, data layer. This is application of for one application of cable. We have to do this for many applications because cable faults are go for a bigger application. Planned is a machine learning model. So once you aggregate the data, the question of intelligence comes. So the machine learning is the intelligence. How does the data in its module? So your algorithm is the intelligence. So in the case of cable system, failure. So in all our applications, whether it is with power data or power or with, we have to go from module 1 to module 2 in creating algorithms. As a demonstrator, Harsimran has only created one algorithm. Module is completed, we come to the third module. This results that we have given to the end users. So the health related information of the signaling asset given to the handheld devices, signal senior section engineers, SMS, maintainers, so that they can do the maintenance and necessary action. For example, if they get a feedback that this cable is bad, infrastructure, his men and material, and have the cable replaced. Give it to him is a front-end application. In some method, he will get he'll get an alert. The database will trigger, and then the front-end application will get an alert that you have to get this cable repaired. Since we will go for more and more data, it will not only with the signaling cables. If you have more assets into this mapped into this application, numerous types of alerts will come, which may not be relevant to everybody. So you have to tightly channelize your alerts to the concerned person to take advice to him. And finally, the fourth module, to of failure maintenance activities devices. This is a basically administration effort. Yes, this is basically a feedback mechanism. So these are the four models that our engineers have proposed. The work that shall be assigned, and the team of people who will now understand not only and many other items that they can start using for their artificial intelligence efforts, using algorithms and feedback methods. Next slide. Can be put up in a small flowchart is that each problem has to be defined, has to be prepared, complex relational databases, and destruction of data from them in SQL and non-SQL algorithms. Algorithms makes the system intelligent. Does not end. You have to improve the results, correct your algorithm, and run it. All these will be run behind the system. It will not be in the front end. And finally, you present the results whenever you are satisfied that, like what Harsimran has done in case of power cables, you can present the results only when you are successful. You have correctly predicted a failure. So this is the basic methodology. The next slide. System is because we have huge amount of data in our data loggers, and you have 109 data logging stations and 72 RTUs in auto sections and LCs. We have 4 servers. Three of these servers have 2 terabytes capacity, 6 terabyte capacity. Of these captured in this data logger for a period of time is 6.6 terabytes packed up, and again a fresh data is captured. What we should understand is that this data loggers do not capture continuous data. It is a Microsoft activities of the systems, but it logs events, the relay status, and the data from the cables. Data from the sensors analyzes this data system, status of the system, processor that filters the data, and you have some noise reduction in the form of different type of PCs, and finally the server stores the data. But what is important is that this whole data logging system is a proprietary of the person who is maintaining it, and we have so far not harnessed the capabilities in developing and reducing human interference. Next, sir. Specific about which we would expect IIT Madras to give us a lot of input. Database for artificial intelligence. Like the purpose of the database is to speed up the machine learning. And if you take a small problem and a little bit of data like what we have done in power cables, the machine can work. It's working in parallel and then feeding data and then artificial intelligence database. The thing is, these machines, these database to machines data, which is fast moving and complex. And within milliseconds, they have to give results because the data is continuously changing database server. So this is something that we expect IIT Chennai to help database creation and the intelligence, how we artificial intelligence. Next. More into this, there are two types of technologies available. You have SQL database and no SQL databases. Only SQL. Databases are relational databases. And from the time of client server applications, we have gone into artificial intelligence applications, open source applications, SQL databases. And the difference between a SQL database and a no SQL databases, it comes in a variety are different. It comes in a variety of based on the data model. Most of our databases are tabular. You have fields, or yes or no field, things like that. But these are non-tabular and stored differently than the relational databases. Applications involving these such of databases are time uses. So these are the technologies where we want IIT to help us, because we have very little exposure to this. We have more exposure to applications. Now we have talked about the back end, which is to look at the front end. We need a software that helps us to code the intelligence, and it should be readable and concise. There are hundreds of applications for coding, but we need to identify the code now, because we don't want to go into one more proprietary type of problem where we do software. All over Indian Railways, we have introduced SAP.
I think we are missing your voice now.
Can you hear me?
Yes, yes. Now we can hear you.
Yeah. While complex algorithms and versatile workflows stand behind the machine, it's easier to build models of machine learning. What this means is that, as Harsimran explained in a slide, there are three parts to the application. The back end are the other two parts of the triangle. While these applications are running, the code should run the code. The code should collect the data from the, impart the intelligence into it and give us the result. We don't know what the server will be. We can't keep a server in our office and expect the whole Chennai division to run on it. We should expect that this application will run on. This is where the technology is involved, that we don't go for an absolute technology. We should go to that type of codes that will come. We started with, we went to web-based .NET technologies. They are all obsolete now, and now we have come to proprietary SAP technology. At least here we should ensure that our code is written in the correct form for the next 15 to 20 years. Next. So this is the roadmap which Harsimran and Babu have. Module 1, they say, is called it's called a literature survey. This includes identifying the data acquisition of different applications, study the methodology to make a minimum viable, validation and creation of machine learning algorithm, testing the algorithm for accuracy. This is the literary survey which he has given a small timeline in April, But as you know, in a software development, very clear about timelines. It can run, like he may develop a few models and the other modules will still keep running. The second module line that he has given is for something called as technical specifications, that is technical specifications, which will include different type of applications like point machines, power cables. We have to create a detailed literary survey, a test plan for each of this. This is also a little, assuming it will also come under the prototype. In the prototype, validation and creating of machine learning algorithm for and testing of the MVP with simulated test data as per agreed plan, and deployment of the MVP is involved. This will take a lot of time from April to December. That is the anticipated time. And for the most viable product, that means his minimum agreed terms of reference will be complied in this module. The third phase of development will be the actual development of the software, refinement of the MVP to cover all aspects, additional parameters into the algorithm for incremental learning, interfacing of additional devices with the database for extra parameters, deployment of approved computing resources, provisional of an allotment mechanism, and visualization. This will come under the third phase, that is the developmental phase. Up to July 2021, it is envisaged. July 2022. And the fourth phase will be to stabilize and test it, testing the functionality and achieving a required accuracy and final deployment of the product, which he has given a timeline of another 4 to 6 months. And we have the of December 2021. And after the assignment, the final release in December 2022. So these are all different lines to go forward with this, at least as to enable us to work on a challenging new field we have now seeing in the future, and to do an early start so that we can lead other projects and be of assistance to others also. Next slide, Harshim. I'd like to thank all of you for listening to me once again.
Thank you so much, Mr. Mahesh. It was an excellent presentation, and I am told that you have to go for a meeting. So I think we'll take up questions for you as well as for Harsimran, if there are any questions. Mr. Murali?
Sir, we are having one question from Shri Kumar, sir. To